the main thing, just remember, like what we're trying to do is essentially before and after, right? Like, or another way of thinking about it is like, given this situation, this is what I expect my method to do. All right. So in other words, it's like person, class, right? If I pass through these inputs, then I would expect that the output, right, is like it's assigning the property, right? It's assigning the attribute. So here we're like asserting that this is what I expect. Okay, here's kind of the setup, here's the input, and then here's the effect. Find or create by last name. So things get a little trickier, right, when you involve a database, right? Because think about what's given here. Like here we are providing, okay, the guy's name, the last name, right? The business entity ID. I guess this is some of the inputs given these arguments to this method. But the other input is, well, it's not just that we're passing through SAM1 and a last name of OK, but also that SAM1, given that SAM1 exists in the database, we expect to return him, right? So what does that mean? That means, again, not only do we need to pass through these arguments, but we also have to, so the setup is, one, pass through the arguments, and two is insert SAM1 into the database, right? And probably what we want to do is it will kind of say something like, given multiple records in the database, including one matching one, right? When I pass through, like, when I pass through, search for a specific record, it returns that record and does not return the ones that don't match. So, right, like that's really what this is about. When I pass through this, we get back someone who meets all the criteria, and we don't get back any others. So what does that mean? That means that we first, before calling this method, we need to insert people, some people that match the criteria and some people that do not in the database. So how do we do that? Well, that's where you have this build people, right? This is our fixture. And you know that this is our fixture because it's an argument passed through the test, right? Passed through this line, not down in the body of the test, but actually here. Okay? So PyTest will see this, then it will look for a fixture named, right, that has that name. So here's build people, and then I can press like Command F and look for maybe def build people, right? I'm trying to show tips on how to navigate a code base as well, right? So def build people, you notice that we have the pytest.fixture surrounding it. So this means that once it sees that test, it's first going to make sure that it runs this. And what do? We clean our database, right? Clean our table. Then we build the records. Then we yield to the test, and then we clean up our mess again, right? So building the records here is what inserts SAM in the database. Both the matching SAM, right? Because it's 1, 2. I guess it's just 1 and 2. I guess it's just two people, SAM1 and SAM2 in the database, right? And one of them match. Okay. Before I move on, I'm going to talk about now maybe how you would write tests for the relational method. But before I do that, questions about this, about the tests? Right? So we insert a couple people in the database. We call the method. We say like, okay, this thing better, hopefully this finds him. And then we check that it found the right person, right? And because it's find or create by, right, we also check that, hey, this person exists in the database, so it's not going to create a new person, right? We still only have two people, just like we started with. Yeah. one thing to point out about tests is, like, if you were going to do this in the console, right? It's like, how would you figure out that your code worked? You know, like I feel like everyone does this when it's just like, all right, how do you check your work? Well, you'd have to create a couple records in the database, some that match and some that don't, and then make sure that your function found the right one, right? Like that's exactly what we're doing. Create a couple records in the database, right? Some that match it, some that don't. Call our method, and just like then look at what's returned, and that's what this part is. Just look at the return value. You know. So I feel like a lot of you all do this naturally, but it feels just a bit weird when you have to write it out in a test. Okay. Okay. So now for the relational methods, think about what that would work. It's like, what do we want to test? Like def test person has addresses, or person addresses returns an individual's associated addresses, right? So what do we need? I'll just put this here. So what do we need for the setup this time? Well, not only do we need a person, but we also need associated addresses, right? And maybe more, and maybe more than one, right? More than three or whatever, or like probably like multiple associated addresses and maybe some non-associated addresses, right? And then what's the test? Assert person.addresses returns only the related addresses, right? So maybe this is like address, 1, this is 82, right? And then here's 83 that's not associated. We would expect person.addresses only to return 81 and 82, okay? So now how do we go about implementing something like how do we provide this setup, right? Well, we have people in the database. So what you could do, to get the person, you could probably just call the find, right? We have this find method, I think. Right, we have this method. So we can just import it and then make sure from api.lib.orm import find. And now down here, we can call find, pass through our test cursor if it exists. The class is the person class, and an ID, right? By ID we mean the business entity ID. So we could say 1, and this should be a SAM1, right? And then what we want to do is call SAM1.addresses, right? And we would expect that this returns the first 2 addresses, essentially. We'll have to, we have to say, we have to check qualities of each of these addresses, right? So you could say, assert that the length of the addresses maybe is 2, and that maybe the first address is, I don't know, that maybe that each of the addresses is related to SAM, something like that. But we'll get to that. Assert each address is related to SAM. Okay. So again, so what do we need to do for this? Well, the setup is we need to have addresses that actually relate to SAM in the database. And right now, we don't do that, I don't think. If you look at this build records, build people calls build records, which gives us some individuals, right? I don't love the naming here, but we'll keep it for now. And then the next thing we want to do is create a couple addresses. So we need to do from api.lib, from api.models, Do I have a yeah, we have an address. From API .models.address, import an address. So we should be able to, this is what an address takes. You can see it takes a lot. It's kind of annoying. Just quickly, I'm going to do this in the, I'm just going to copy some code. I think I have it here. Here is an address. So we'll just move this over. Okay, so we're creating an address. You can see it has an address ID. We're just giving it that. We can, here's the address line where it is, some postal codes. We can make this dynamic, I guess, by saying for I in range 1. We don't have to. We'll do it for now. We'll keep it the same. What we'll do is we'll just we'll say it's going to be the ID. I just want to maybe like have a different ID for each one. So we could choose a random number. We'll just say that it's whatever I is plus 10. Okay? Just for now. Okay? So we're just giving it a random number, basically. Just because I want them to be different. As we create multiple addresses, I want them to be different. We have to save the address, save each address, right, to the database. And then what's next? Right, we're creating these addresses, but how do we actually associate, like who are they associated with? Right, how do we associate them with a particular individual? So the way to do that is through the join, right, through this thing. So we need to create a business entity address we create a business entity address, and this is saving this means that we are saving a record in the database that has both the address ID and that person's ID, right? So if we do this properly, then this will link an address to a person. So what we can do is let's just copy this real fast. I just want to have these keys. So the address ID, well, what should that be? That should be like this address ID. So if I want to link this address, create a link for this address, I'll just take its address ID, right? And then if I want to link it to an individual, Sam, then I'll take Sam this will be the business entity ID Sam what am I doing? This will be Sam.business entity ID. Isn't this one? Why is this complaining? Positional argument, because I need to do business entity ID. I need to do this. So I'm setting the address ID equal to this thing's address ID, and I'm setting the business entity ID equal to Sam's business entity ID. So basically what I'm doing is I'm twice, right, for I in range 1 to 3, so meaning for numbers 1 and 2, create Sam, just give him an ID of 1, right? Save him to the database. Then create an address, give it basically a random address ID, and associate the person I created with an address by creating this business entity address, right? And then I think I may also have to store you can see there's this one more attribute of address type ID, I don't know if I can just give this a, let me see, can I just give this, I can just give this a number. So we'll just give this a random number. The address type ID is probably like, is it an apartment or is it like a home? Like a single family home. All right, so this is how you do the setup, right? Because I not only need people, I need people that have associated addresses. And then I can call business.addresses, right? And what it will do is select all from the database where joining this business entity address, right? Where the ID is like Sam's ID. Does that make sense? So now let's see if this worked. We can put, we need to call this method here. We want to call the fixture. So that means we should call build records. And if you want, like we can put a breakpoint here. Let's see if this works. So do PyTest test person. Oh, test models, test person. I broke a lot of things. Save missing 2 requirements, connection and cursor. Fair enough. And let's just take a look. Where is this happening? It looks like this is happening when I'm doing save address, right? And build records. And it's even telling me that if I click on testperson.py, line 16, see that? It takes me right there. So save an address. And also, you notice if I hover over it, it's giving me the arguments I need, right? So I need the test connection and the test cursor. And then let's run the test again. Still breaking. Still sad. Invalid SQL. Delete all from table name. Interesting. Undefined column. Business entity ID does not exist. Interesting. That is happening. Testperson.py line 16. So we're saving address. And maybe someone probably saw it. I think you do have to do, thank you, Christina. Very nice. All right, so I created a separate method for saving an address because this save method assumes that the primary key is like the business is a person's primary key. So anyway, we have a separate method called save address, I believe. Yeah. And now the question is, will it allow me to, so if I could, this will work, but will this thing work? I don't know. What's the primary key here? There is a business entity ID, but it's probably not exactly what I'm talking about. I don't think this will, I probably would need a separate save function for this too. It is actually kind of a hard test to write. Yeah, it's gonna come, now it's complaining. Save missing. Sorry, I may have to pun on this guy. Save is missing 2 positional arguments. This is testperson.py line 27. Build records. Oh, it's because of this thing, maybe. Yeah, here, I'm breaking on the next line. I forgot to do it here too. I forgot to pass through the connection and cursor. I think this is going to break anyway, in which case I'll probably skip it. So we're saving, if you think about it, just to make this more clear. Here's my business entity address, and then we want to save it, and then also provide the test connection and the test cursor. All right. So again, just to reiterate, what we're doing in the setup is because we're testing that when I call person.addresses, it returns the related addresses. We need to associate addresses with a person. And the way we do that is not only by creating a person, but by creating an address and then associating the address through the join. So that's the setup you need to do. The issue I think we're going to run into is this save method may be inadequate for this type of entity. I think it is. It is. We're close. Actually, maybe we're okay. Let's see what happens. Build records not found. Okay, that's because this should be called build people. That's down here. Right, the real fixture is called build people. That's the fixture. All right, I don't know. We're doing a little better. So now you can kind of like check, like, did our data load, right? So for instance, we have the test cursor, right? You could do like, you could just, like, at this point I might just check like that our data looks okay. So test cursor.execute, right? Select all from person dot address. Like, do we have cursor dot fetch all, right? And we have some addresses, right? Let's see the length. That doesn't make sense. Oh, because I called fetch all twice. Let's just do this one more time. These are my addresses, address records. So these are my address records, and then we can like look at the length. Yeah. Okay. So we're creating some addresses. I think maybe we're not dropping. Oh yeah, we're not dropping them, right? So you can kind of see like there is more work to this than just that. We have to make sure we drop them probably each time, and then but we are loading data in, and that's kind of the first step. Cool. I feel like we kind of went through this enough for you to get the idea. I would rather you try to, even if you don't succeed, that you like look through this and try to implement a test for this and maybe get further than I did. Because this is the process, is like, and it's just understanding that process of, okay, I want to test this method. What does this method require for me to adequately test it, right? Well, what does this method do? It returns Sam's addresses related to Sam. So to properly test it, we need a scenario where we both have addresses that relate to Sam and addresses that don't. And then what we are testing is that we only get back the addresses that are related to Sam. Yeah? Like I said, we can give a proper, like, another lab on testing, but I think for now, just trying to work those muscles is pretty good. All right, questions before so what I'd like you to do maybe for the next like 40 minutes or something is, one, just review the quiz, right? Review the answers and look through them and try to understand, I guess, like this query and how we went from this init that first finds an individual person and then essentially calls person.addresses through this toJSON method, right? Person.toJSON calls addresses. And remember, how can you navigate code? Well, you can read it, obviously, but another way to do it is breakpoints, right? So it's like if you are like, well, you can call the run.py, Python 3 run.py. This boots up the Flask application, connected to your development database, right? Because that's what we're doing here. And then if you go to the init inside here, you can see which routes you can kind of check. And let's just hope they work. So it's localhost 5000, I think. Yeah, this is 5000 / addresses or something like that, right? And then here's the addresses. And now, right, to make sure you hit your breakpoint, you can hit the route and then put a breakpoint where you find appropriate. Okay, so for this one, you could like find an individual. Persons. Let's go to /persons. This is what I would do. We see this business entity ID is 1. Right? And so to hit this route, what we need to do is /person/addresses/1. Right? And that returns this person as well as their related addresses. And now from there, like, how does that work? Well, that has to call, well, I guess the find method and then person to JSON. So if I go to person to JSON and I want to see how this works, right, I can put a breakpoint here. If I want to dig deeper and see how this works, right, I can put a breakpoint here, right? So it's like call the boot up Flask, right? You can run the test and put a breakpoint, but you can also call this run.py function, and then by going to the proper URL, making sure that it's hit, that it's reached. All right. Cool. So yeah, so we have this, we make a request essentially, and we get this dictionary. And we want to turn the dictionary into an instance, right? Like each dictionary into an instance. So let's just call this like, our first receipt, okay? And so that's that, receipt dictionary. And now we want to like kind of, fit this thing, like how do we get this into this, like to be one of these, right? Well, you can look, we have these arguments of like what's the total, what's the address, what's the end date, and maybe what's like, the restaurant's name. The end date, I believe the one that actually changes is the obligation end date. And now, if, we can just start with a single receipt and solve it for that. So if we have this first receipt and I want to create a new receipt instance, well, right, I need to like, just pass through somehow, right, like the total. Why is this not? I think I have to. Okay, so do total equals some sort of total number, and those say the address is some address. We're going to have to define these variables soon. And the end date equals some end date. And then the restaurant name equals some, name equals some name. All right, so the restaurant name equals some name. Okay, so now we have to define these variables. So we have this first receipt thing, and we just have to pull out like the proper ones, I think. So I'm just going to do first receipt.keys just so I can see them a little bit easier. And the total is total receipts. Okay, so let's just call this thing, yeah, that's fine. So we'll do first receipt, square bracket, because this is a dictionary, right? So if I want to get the total, that's total receipts. And let's just call that my total. And then we'll do the same thing for the next thing now. Here's the address. And what is that? That's going to be, do we have a taxpayer address, something like that? Or is there a location address? I think it should be the location address. And then we'll do the same thing with the end date. And that would be the obligation end date, I think is the right one. I'll put that to end date. And then the restaurant name is the name. Maybe does it have a name other than location name? That's probably it. The same thing. So now you can see, if we just press shift return here, we can start to see that this is, I believe, like what we want, There's the total and the address and the end date and the name. This is all starting to look pretty good. And we can just pass this through. This is a receipt. I know that it could have been implemented otherwise, and maybe even better, but this works. So just take the data, right? So what do? It's like define a class, say, hey, these are the attributes we want. Like this is what we're working with, right? And then pull out that data, and then we can take that data that we pulled out and create a receipt from it with that data, right? Total, address, end date, restaurant name. And this is looking pretty good. So then the next thing to do, so it's like we're got back to our old trick, right? Which is, all right, we have something that's a little complicated. We have a lot of entities, a lot of these dictionaries. So instead of working with them all at once, just solve our problem for one and then do it for all of them. So what we can do is we can say, okay, here's my restaurant receipts. And now that we solve for one, let's say for restaurant receipt in restaurant receipts, do the following. First, pull out the attributes. So let's change this all to restaurant receipt. Right, so I'm just, if you think about it, we can print these if you want. All right, so for each restaurant receipt in the list of dictionaries, let's just print out, right, the relevant attributes. And that's doing okay. And now instead of, so you can see for each one we're printing out, and I guess the main thing that changes, at least, is like hopefully the end date. And that you can see this date is changing, which is nice. All right, and now instead of doing that, we can just create an actual object, right? I can just do receipt and pass through. Let me see. I want to make sure I'm passing through things in the right order. So we'll just pass through this. Why did I do it that way? Receipt. E-I-P-T. I spelled this word wrong. Okay. That looks okay. So for each dictionary in our list of dictionaries, we are going to retrieve, like just pull out the information we want, right? Get the total, get the location, we can store them at each to a variable, and then pass that data, right? This total into a new instance, right? And we know that our instance kind of catches it over here, right? And then what do we want to do? We want to hold on to each instance, right? They're nice little things that we created. So I will create a list. Why do I keep doing that? Receipt of the list of receipts equals this. And then we'll append. So receipts dot append the receipt. Yeah? And now we should, if we look at it, right, we can see that we created, one for each dictionary, which is our goal. Why is this our goal? Well, because now we can have methods, we like methods, right? Like we can do like a lot of, like we can like write a class method to maybe find the receipt that has the max total. Or we can write, if we kind of added more attributes, maybe we want to do total from alcohol or something like that, as opposed to and that adds up these three things. So for each instance, we can, have this instance method that all of a sudden we can call. Or, maybe we don't like the display of this and we want to lower it, etc. All right, so now you can see we have this list of receipts, and each one of these receipts, if you look at it, right, has our attributes here. All right. So another reason why this is so nice that we have objects now is because think about our whole goal, right? Whole goal is that we're pulling data from an API. We're turning these dictionaries into instances. And now with all of our receipt objects, maybe for each one, we can save it, something like that. And what would that do? Oh, sorry, receipt. Right, if we have that save method, that knows how to take an instance and save it to the database. Right, because underneath that save method, we'll call that insert into statement. So this is kind of like right? The first, we want to, this is a little messy, and it will get more messy over time. This is also part of like our code base. So, so far our whole code base, if you want to look at everything that we're using, is it's this. Sorry. It's this. Create a class, make it so where we, that takes these 4 arguments. Then we make a request to the API, get back dictionaries. For each dictionary in the list of dictionaries, select the proper attributes, turn them into an instance, and then potentially, if we want to, we can save them. Right? We can't actually do this quite yet. Save them to the database. Yeah, William?
Is there a reason that you're moving away from the KW args strategy and like attributes?
No, not really. It was just that originally I taught this earlier than this came earlier in the semester.
Okay.
But yeah,
Okay.
no, using the using the quarks thing, well, that works fine. What I would like you to do though, like one thing I saw, in some implementations was like trying to initialize everything, like pass through everything, and then just select the data down here. Notice kind of what we're doing is selecting the data before we insert it. Why is that important to do? Because, well, what if this data comes from the database, right? In this case, the data is coming from the API. But remember, we're also going to want like a build from record method where the data comes from the database. And all of a sudden, yeah, like the database just has like these 5 columns, right? Like it's not going to have all this extra crap from the API where now, I need something that's like, oh, when I initialize, first, only select what I want from the API, right? Like this thing should be able to handle both. Like sometimes from the API, sometimes from the database, right? So this thing actually has no knowledge. Like there's nothing particular to the API here, right? Like let me put this another way. What if I wanted to like pull data from a totally separate API that has like separate keys, so that there's nothing. So instead of total receipts, it's just called like receipts, or maybe it's called money earned or whatever. That's fine. This code changes, right? But inside the class, nothing changes, right? I just pull out the relevant data, money earned, and then I do the same thing. Receipt total equals, this would be called money earned. It doesn't really matter. I'm passing through this value. But what's nice is like my receipt class is staying the same. All right? Right? To it doesn't care where it got the data from, whether I got it from the database, whether I got it from a separate API. It doesn't matter. This code is staying the same. What's different is how we're taking data from the API and turning it into an object. That's happening outside of the object. I think that will make more sense over time, but that is very valuable, right? If you think about like Spotify API, like we could be getting some data from like the Spotify API and some data from like the Apple, like iTunes API. In both cases, we're gonna want to, maybe take that data and load it into the database and probably just have one class, right? Like it should be the same table that we're loading data regardless of whether it comes from Spotify or iTunes. Where would you put the for loop in a code base? Okay, perfect question, right? Like, doesn't this thing belong in its own, I don't know, somewhere, not just here. So yeah, what do we do with this? We're gonna create something called like an adapter or a builder, and we will and we'll do that here. So maybe we'll call this like a run method. And then all of a sudden, all right. So we're going to have a class whose whole job, and this is like the next lesson, is to take data from that's in one form, a dictionary, and turn it into an instance. That's it. That's what it does. Okay. And this is a very typical kind of pattern called like the adapter pattern is what you'll hear it as. People also may just refer to it as like ETL in Python. Okay. Where ETL, right, stands for, if you think about what ETL stands for, extract, transform, and load. So what are these? And we'll review all of this in the next class, obviously. So what is extract, transform, and load? Well, what's extract? Extract is this part. Hitting the API, pulling data from the API. Sorry, getting this list of restaurants receipts. What is transforming? Turning each restaurant receipt into an instance. What is loading? Was saving the receipt, right? Loading it into your database, right? So you can see that just by, like, how did we get there? We started by just creating a class and then saying, okay, we want to take this data, a simple for loop, and just loop through it for each restaurant in the list of dictionaries, pull out the relevant data, create a receipt instance out of it, right? And then what do? We just wrapped it in an object, you know, like just place this code in a method so it's not just hanging out there, and then, you know, wrapped an object around it. And now what can you do? You can just call, like, you know, we're going to have to build on it because now this code is kind of just disorganized. So we'll deal with this later. But, you know, what you can do is just like call adapter.run. Or like, and we can show you this. So let's take this code. This is the same code. It's just, all right. So what does this run method do? This is what we saw before, right? So we get these lists of restaurant receipts, and that will give us like our list of dictionaries. So we'll start here. And then we can create a new adapter instance, right? And this so I'll do adapter, create this, all right, I'll call this my adapter. We'll call this my restaurant adapter. All right, so this is an instance, doesn't have much data in it. Let's declare it. All right, here's my instance. And it has one method so far, just called run. Okay, when you call run, I should return this, shouldn't I? When you call run, what will it do? It'll go through the list of dictionaries that we pulled out from here, from the API, select the relevant data from each dictionary, create an instance, and return a list, I think. Oh man, what am I forgetting? Tell me. There you go. Only one. I must have forgotten something. Oh, look, the typical error. Wait, for each one, yeah, the typical error, right? If my return is indented. How many times have we made that mistake? Okay. There we go. All right. Okay, you guys know everything now. We'll go back through this. All right. But this pattern, right, it's taking that step of pulling data from your API and basically breaking it into three different steps. One is extraction, making the request, 2 is transforming, converting it into a model layer, right, into an object. And 3 is kind of saving it into the database, but that model layer, right, that model layer itself is considered, right, a step. This is the third kind of component. So it's like to really, generally what you want to do to like pull data and load into an API, you have 3 kind of steps: pulling the data, transforming the data, and then like the data layer itself, right, the receipt. Okay? And then you actually just insert it into the database with a call to save, right? Save the receipt. So we'll pick back up there tomorrow, all right? And just, review and have you all implement this and, practice this some more from there.
Jeff, can you share this?
Yeah, sure. Good idea. I'll save this, and then I'll put it in Slack. Cool. All right. I'll see you all tomorrow.